All right, so before we get started, I would like to review difference of squares, because on some of these types of factoring, we are going to have to remember how to do difference of squares. Now, in order for us to use difference of squares, what do we need to have?
Perfect squares.
Yeah, two perfect squares. So, difference of squares, well, that's too big. You have two perfect squares, so a squared and b squared, and what else do you need? Subtraction between them. So this turns into what? A plus b and a minus b. That is the difference of there you go. Difference of squares. Okay, so now, who remembers what the difference of two cubes formula was? Right now.
A minus b, and then parentheses a squared plus b squared plus a times b. Oh crap.
That is the formula for difference of cubes. Now, there's a little acronym to help you remember what the signs are here. So the minus and the plus and the plus. The acronym is called SOAP. SOAP. SOAP stands for same, opposite, always positive. Okay, so it's the same sign as the original, opposite sign as the original, and the b squared is always positive. The reason you kind of want to know this acronym is because the sum of cubes uses the exact same acronym. Now it's the same sign, so plus b, then a squared, opposite sign, so minus a times b, and then always positive b squared. Any questions on that? So now, what we're going to do is we are going to apply these formulas to factor different types of polynomial functions or expressions. So here we have x cubed plus 125. What do you think is the first thing we need to ask ourselves? Okay, good. You're on the right track. But before we even start factoring, what should we always look for? GCF. Is there a GCF here? No. So, we do recognize, what is the cube root of 125? 5. What is the cube root of x cubed? X. So, are these perfect cubes? Yes, they are. So, we can use sum of two cubes. So, our a value is just going to be this first term cube rooted. So, what was the cube root of x cubed again? X. And what is the cube root of 125? 5. So our a term is x and our b term is 5. Knowing these two values, all I have to do from here is just plug them into our formula. So our formula has us putting what first? A, which is what? X plus, what's b? Times x squared minus a times b, which a is x, b is 5, minus, or I'm sorry, plus b squared. Now, do you need to write it out like I did every time? Probably not. I just want to show you that we're literally just putting numbers into a formula. And now, how can I simplify this a little bit? How can I refine this?
X plus 5, x squared minus 5x plus 25.
Beautiful. That's our answer. This is as factored as this can get. Now, I'm telling you it's as factored as it can get, but what should we, on other problems, check for, do you think?
Oh, we already did.
Which one of these, x plus 5 or x squared minus 5x plus 25, do you think could possibly be factored a little more? Yeah, you would need to check to see if that quadratic there is factorable. Which you would just quickly ask, okay, do two numbers multiply to get 25 but add to get negative 5? No, I can't think of any. So because x squared minus 5x plus 25 isn't factorable, this is the simplest factored form. And we're done. Okay, now let me show you difference of two cubes. So, what do we ask ourselves first? Before that, is there a GCF here? Does 3 go into 64? Yeah. So, no, there is no GCF to pull out here. So now we can ask ourselves, are these perfect cubes? And are they? We do cube root of 27x cubed. What is the cube root of 27? What times what times what is 27? 3. And what times what times what is x cubed? X. So the cube root of 27x cubed is 3x. And then what is the cube root of 64? 4. So now all we do is again plug these values into our formula. Okay, so first it's a, which is 3x, minus b, which is 4, times 3x squared plus 3x times 4. Oh no. 3x times 4 plus 4 squared. So how can this be simplified a little bit?
Why do you put the square on the outside of the parentheses for like 3x?
Ah, good question. Our a value, is it just x? When we did this, was our a value just x? No, it is 3x. So when it says a squared, you need to make sure that you're squaring everything that is a. So you have to also square the 3.
What about the 4?
Same thing. Square 4.
So do you have to have parentheses on the 4?
Probably not.
And then is the 3 in front of the like radicals just to show that it's being cubed? Like up at the top.
Yes. So if I didn't put a 3 there, it would just be square root. But we're not square rooting here, we're cube rooting. Yep, the 3 means cube root. Okay, so what is 3x squared? What is that? So we square 3x squared, and we get 9x squared, and then 3x times 4 is 12x, and 4 squared is 16. And then we would check to see if that quadratic is factorable, which it is not. So this is our final factored answer. So on number 2, I said, what do you look for first? GCF. So what is a GCF that goes into both 16 and 54? 2. So you can pull a 2 out. What is 16 divided by 2? So we have 8x cubed. And what is 54 divided by 2? So now this is a what? Perfect cubes. This is difference of cubes here. So we do just like we were doing before. We find our a value, which is the cube root of 8x cubed, and we find the b value, which is the cube root of 27. And then you just plug those in, keeping the 2 out in front. Okay? So you guys keep going on this problem. Keep trying. So what did you guys get for number 1?
X plus 2,
parentheses x plus 2.
and then x squared minus 2x plus 4.
Beautiful. Any questions or anyone need me to explain how we got that? And is x squared plus or minus 2x plus 4 factorable? Are there two numbers that multiply to get 4 but add to get negative 2? No.
What would we do if it was factorable?
No. You'd factor it. If it was factorable, you'd go ahead and factor it. So then, over here, what was our a value? 2x, and our b value? 3. So, our formula says, what comes first? Good. 2x minus 3, and then?
4x squared plus 6x plus 9.
Anyone need me to explain how we got that? It is 2, you're right. It is 2x squared, but remember, we're squaring everything that is a. So not only do we square the x, but we also have to square the 2. So what is 2 squared? That's why it's 4x squared plus 6x plus 9. Any more questions? Is 4x squared plus 6x plus 9 factorable?
You'd have to do group.
You would have to do grouping, but what is 9 times 4? 36. Are there two numbers that multiply to get 36 but add to get positive 6? No. So this is not factorable. So this is the factored form of that expression.
Would we ever have to do the quadratic formula? Or like...
So good question. Today, you are just being asked to factor polynomials. Is doing the quadratic formula factoring something? What is doing the quadratic formula doing?
Finding solutions.
Solving. So no. When you're being asked to factor, you do not use the quadratic formula. The quadratic formula is for solving only. Okay? I know over here it says, somewhere it says use the quadratic formula. I don't know where. But that's only if you're being asked to solve it. Okay, so now on to the next way to factor. So that was just one way to factor a polynomial. If you have two perfect cubes, you're going to use sum or difference of cubes. Here, if you have 4 terms, you are going to be using factor by grouping, which we are already familiar with. So here, it says, factor by grouping. Use when you have 4 terms, and you're splitting the terms into 2 groups. Before you even do this step, I ran out of room when putting these steps in, but before you even do these steps, what should you look for? Always look for GCF first. Good. So then you have 4 terms. You split them into 2 groups. You pull out the GCF from both groups. We've done this over and over again while factoring. The first factor is the terms on the outside, the GCFs. And the second factor is the repeating terms on the inside. None of this is new. Then, so now is where you have to go a little further. Now you look for another GCF to pull out, or look for a difference or sum of cubes or difference of squares. This is why we reviewed difference of squares to begin with. And then you repeat this until it's fully reduced. If there are 2 factors that are the same, rewrite as x plus h squared. So I know this is all, this bottom part is probably all gobbly glue. Oh my God. It's all gibberish to you, right? I don't know what I was trying to say. Gobbledygook. It's a saying. Oh well. So, example 1. Is there, or what should we look for first? A GCF. Is there one here? No. So what does the first step say to do? Split into 2 groups.
Oh, so you don't do like the x. You just
No, you just immediately factor by grouping here. Immediately group them. What is a GCF I can pull out of the first 2? X. Oh, I forgot to tell you. There's a little bit of a misprint here. It shouldn't be 5x squared. It should be 5x cubed. Put a 3 there. Yes, so I can pull out an x cubed here. And then I have what on the inside? X plus 5. And what can I pull out of the second? No matter what, if you pulled a GCF out of the first, you have to pull a GCF out of the second. So our greatest common factor here is just 1. So now what tells you that you did this correctly? Ah, yes, inside the parentheses is the same. Now, if it wasn't the same, and you know for a fact you did everything right, and there are 4 terms, it means that this problem is unfactorable, okay? We won't give you problems like that, but just for future reference, if the insides weren't the same, it means you can't factor something out. So, what is our first factor? X cubed plus 1, our GCFs, right? So x cubed plus 1. And then what is our second factor? X plus 5. So now's where it gets iffy. Step 4 says look for another GCF to pull out, or look for difference / sum of cubes or difference of squares. Do we have any of that here? What is the cube root of 1? 1. So what is x cubed plus 1? What do we call that? X cubed plus 1. Ah, good. I'm glad you got that. X cubed plus 1 is a sum of 2 cubes. So we can use the formula that we just learned to break this up even more. What is our A term here? X. And what's our B term? 1. So in our formula, what am I going to write?
x plus 1, and then other parentheses is x squared minus 1x plus 1.
Good. Now I just split my x cubed plus 1 into those 2 factors. What am I missing? What do I need to rewrite? I need to bring down the other factor that is still there. It didn't go away. Now we ask, x squared minus x plus 1. That is a quadratic. So we need to ask ourselves, is x squared minus x plus 1 factorable? Are there two numbers that multiply to get 1 but add to get negative 1? No. So this is in simplest factored form. I'm done.
Oh, do you not have to like do the FOIL thing? You don't have to like do that since there's so many.
So okay. So do I need to FOIL? No, I just spent all that time breaking stuff apart. I'm not going to put it back together. And Haley, what was your question?
Since you have the x plus 5 and the x plus 1, do you you combine them?
So same question. Are we trying to FOIL and box method to put those together? No, we just spent all that time trying to break them apart. It would be like adding and then deciding to then subtract. Well, then why the heck did you just add? Don't go backwards when you just went forwards. So, next example. What do I do first?
Parentheses. Or GCF.
Aha! What do you always look for first?
GCF.
GCF. So what's my GCF here?
3x.
X cubed. Pull an x cubed out. What is x to the 6th power divided by x cubed? Good. What is x to the 5th power divided by x cubed? Now what are we doing here? When we're dividing variables with exponents, what do you do to the exponents? Subtract. Good. So all we're doing here is x to the 4th power divided by x to the 3rd power. We're subtracting. What's 4 minus 3? 1. So it's just x to the power of 1. And then what is x cubed divided by x cubed? What is 3 minus 3? 0. It's just 1. Yep. Because what is x to the 0 power? Is it 0? No, it's 1. Okay, so now what? Parentheses. Now we factor by grouping. We have 4 terms. I know whenever I have 4 terms, I factor by grouping. So group the first 2 and group the second 2. What GCF can I pull out of the first 2? X squared. And what am I left with on the inside?
X plus 1.
Good. And what can I pull out of the second 2? Good. And what am I left with?
X plus 1.
Beautiful. So now how can I rewrite this?
X cubed parentheses x squared minus 1 and then x plus 1.
Good. Am I done? Why am I not done? Perfect cube? Perfect squares. There's a difference of squares here. Now, if this had been a plus, if that had been an x squared plus 1, could we have split it? No, it's only difference of squares that we can split. So, x squared minus 1 can be split into what?
X and positive 1.
Yeah, x plus 1 and x minus 1. And what did the last step tell us to do?
If there are 2 the same factors, just make it squared.
Right, if there are 2 the same, so are there 2 the same here?
X plus 1 squared.
Ah, there are 2 x plus 1, so we do x plus 1. What's that?
I keep putting x squared. Do you mean x cubed?
Oh, thank you. Oh, no.
Confusing me. I'm like, Miss Sunderlin.
How did I go down to a square? Yeah. X cubed, and then I have x plus 1 squared and x minus 1. And this is my final factored form. I don't know why, but this is like one of my favorite things to do in Algebra 2. I love factoring polynomials. Because it's like a puzzle. You just keep splitting and keep splitting and keep splitting. I love it.
Exciting.
It's exciting. It's very exciting. So, shh. When you are trying to factor polynomials, this last method is like your last ditch effort. It's when nothing else works, okay, let's try to use quadratic form. Now this is not to be confused with quadratic formula. Quadratic form is when you're taking a polynomial and you're trying your hardest to make it into a quadratic. Because we can factor quadratics. That's what we did all last unit. Or actually the past 2 units. As we were factoring quadratics. So, step 1 says use when there aren't 4 terms and it's not difference or sum of cubes. And always look for a GCF. Then it says replace variable with a variable that you can factor. For some reason I like g, so I always put g equals x squared. Use the x method, factor by grouping, or the quadratic formula. So this is where if it's asking you to factor, you don't use the quadratic formula. Put the original variable back into the equation and you look for more ways to reduce. Difference or sum of cubes, difference of squares. So again, let's try it. X to the 4th power minus 16. Is this sum or difference of cubes? No. Are there 4 terms that we can then group? No. So this is when we're going to use quadratic form. We're going to replace x with a value that we can factor. So we're going to replace x squared with g. Because now, how many g's will replace x to the 4th power? 2. So now this becomes g squared minus 16. Can we factor this now?
Yeah.
Oh, yes, we can. In fact, this is a what?
Difference of squares.
Difference of squares. So what does this split into?
G and minus 4.
G minus 4 and G plus 4. Can this be factored anymore? Like this, like in the state it's in? No. So now is when you put x back in. So now it's x squared minus 4 and x squared plus 4. Can this be factored anymore? Yes, why? There's a difference of squares in front. X squared minus 4. What can that x squared minus 4 be replaced with?
X plus 4.
4? What's the square root of 4?
2.
Good. X plus 2 and
X minus.
can x squared plus 4 be reduced? No. It's a addition of squares, so it can't be split. This is as reduced as we get. This is our answer right here. And that's it. Any questions?
So you just replace it with something that's
Right. Yes.
okay.
Okay? You can use any variable you want. For some odd reason, I like G. I don't know why. You could use Z if you want. K. P. Okay. Now, as a precursor, this next problem I'm about to do is as hard as we're ever going to ask you to factor. So this first initial day of factoring, when you really haven't even tried to factor polynomials yet, this is going to seem crazy. Please, please, please bear with me and do not complain throughout the process. It's very annoying. Okay, so what do we do first? Look for a GCF. What GCF do we have? There is a 3 that goes into everything. What else? We can pull a 3x out. So what is 6x to the 5th power divided by 3x? 2x to the 4th power minus, what's 51 divided by 3? And what's x cubed divided by x? Minus 27x. What is 27x divided by 3x? Beautiful. So now that we've pulled our GCF out, is this sum or difference of cubes? No. Are there 4 terms here?
No.
No. So this is when we try to use quadratic form. We're going to try to look at our leading term, our leading x here inside the parentheses. And we're trying to make this into a quadratic. So I'm going to replace g with what? X squared again. Yep, it's x squared. Because how many g's replace x to the 4th power? 2. So I have 2g squared minus 17. What replaces x squared? Minus 9. Can I factor this? Leave it alone. It's just in front. We're now trying to factor inside the parentheses. So, how do I go about factoring this? Yep. You're going to have to actually do X method and then factor by grouping. So, A times C goes up top. What is 2 times negative 9? Negative 18. And negative 17 goes in the bottom, our V value. What 2 numbers multiply to get 18 but add to get negative 17? Negative 18 and positive 1. Are these our factors? No, why not? We have something in front of g squared, so we have to pull down. Now what do we do? Right, we have to factor by grouping here. So now we have 4 terms. Now we're factoring by grouping. So, put parentheses around the first 2 and parentheses around the second 2. What GCF can I pull out of the first 2? 2G. And I'm left with? And what can I pull out of the second 2? 1. And I'm left with? So my first factor is what?
2g plus 1.
And my second factor is? G minus 9. And don't forget about that 3x that we pulled out in the very beginning. What do I do now? Are these any more factorable as they are? Can I factor 2g plus 1 anymore? No. Can I factor g minus 9 anymore?
Oh, no.
So now what do I do?
You plug it back in.
Yes, you replace g with x squared. So now I have 2 times x squared plus 1 and x squared minus 9. Can either of these be factored anymore?
X squared minus 9.
Ah, x squared minus 9 is difference of squares. So what can that be broken up into?
X minus 3, x plus 3.
Yes. X minus 3 and x plus 3. Can anything here be factored anymore?
No.
No. So this is my answer. I am done. Thank you so much for not complaining. Any more questions on this first?
Would we have things like that on our test?